This is the second session for Docker Swarm administration. And in previous session, we did about the Docker Swarm, how to Docker Swarm setup and initialization, some tasks related to more node management, service management, and network management. So today we will continue with some remaining tasks about the node management and rest of the task. So let me quickly verify my cluster status, Docker node ls. So I have three nodes and Docker service ls. I deleted all the services created in the previous session. So I will create new services for today's topic explanation. So here in the node management, we did all these tasks inspect, promote, demote, ls. So today we have to discuss about the update. We can do node update, Docker node update, availability, and there are three states we can set to node. One is active, that is right now, drain and pass. Drain is used to remove all the workload currently running on any specific node and also avoid further workload scaling. And past state is used to avoid only further workload scheduling, but the current workload be remain as it is. So before doing this, let me just quickly set up a service like Docker service create name. I can say app1 and replicas. I will set some replicas like 6 replicas I want to set on Nginx based image I can use. So why I use 6 replicas? Because I want to span the workload across the all nodes. Docker service ps app1. So you can see node 1, node 2, node 3 all are occupied by with uh, some workload. Now if I do Docker node update availability train, for example node 3. So Docker node ls will show us that one node is in the drain state. And now if I run Docker service ps app1, you can see all the workload is shut down from node 3 and that workload is relocated to node 1 and node 2. So still we have 6 running containers that was a replica set for that specific service. So auto healing happened and that node is now drained and no further workload will be going on this node if we Docker service scale uh, app1 service we want to scale right now 6 to 8, so it will be only schedule on the active nodes. Docker service ps, you can see node 3 does not contain any workload. All the workload goes to 1 and 2 node. Now, this drain is helpful in maintenance mode. If you want to maintain your server, you want to update your server in sense of software or hardware, now we can power down the server and we can do any update and then we can again Docker node update uh, availability to active to node 3, sorry, node 2. So Docker node ls, you can see now, sorry, node 3, not node 2. So you can see now all are in active state. But if right now it does not contain any workload. It does not contain any workload. So when we will scale up the service, if we scale the service to 10, we could see some workload will also go on node 3 because it is now working as normal node. So node 3 does contain two running containers 9 seconds ago. Okay, now if we want to do Docker node update availability to pass, for example, node 2. So now node 2 is set into pass state. Pass state mean no further scheduling will happen on this node, but the existing workload be retained as it is. So node 2 does contain the running states of container. This state is useful if we want to make some worker node mean that node does contain some specific workload and we don't want to overcommit further workload on that node. So in that case, we can pass that node. So now if I do the scale up of the service from 8 to 10, sorry, 10 we already had, to, for example, 15. So all the new workload will go to node 1 and node 3, and node 2 will not get any workload. So node 2 contain the same workload, but the new containers ran on node 1 and node 3. Okay. So this can be a situation, depends on your environment. You can use this pass state. So Docker node, I will resume to active, update availability active node 2 Docker node ls. It is now active. So this was the topic related to this node drain, pass, and active. And we have already done this node removal process in the previous session. So this was related to node management. There is one more command related to node, like I can do Docker node ps and node 1. Similarly, node 2, node 3. So just like we did the PS for the service, we can do the PS for the node, and it will show us only the workload running on that specific node. Okay. So when I ran this command from node 1 and I have not provided any node name, it's mean the node 1 because I am running from node 1. When I will run this command from Docker node ps, it will only give us the node 2 related output. But we can query from any manager node for any node about the running workload. Okay, now this is done. Service management we have already done. Now we have to understand the stack management as well as the concept of secret and configs. So we can run the services from the command line, because when we run the command docker service create, just do hyphen hyphen help, you can see there are a lot of options we can use to create a service. Just like we can set the environment variables. Okay, we can set log options, drivers, CPU limit, memory limits, okay, limits pipets, process IDs, maximum number of processes. So there are a lot of things. And if we want to deploy some application that contains multiple uh, components, different business logics designed in the form of containers, image. So in that case, we have to deploy multiple services for multiple containers for each application component on the same network. So by the command line, it is possible, but it will be quite difficult while managing this. So for the stack, we can use the syntax, the Docker Compose syntax to create the stack. So I have an example here where I just created two services. I will just copy this whole stuff here. It's given here in the video description, also in the Git repo. So for example, I am creating a file here like app2.yml, and in this file I will just copy this whole stuff. And here I am just going to remove this config right now because we have not understood the config. Here services, how many services? One service is web and one service is DB. This service is using this image, and in the under the deploy option we can define the replicas, max 3 replicas it will create. CPU and memory resource limit is allocated. Restart policy on failure automatically be start. Port exposure, how it will happen, and which network it want to connect. Okay, by default, if we are not going to define any network, for example, I'm not going to define any network, it will automatically create a network. I will show you. I'm not going to create any network. And this is a DB, and this is an environment variable for the database. And right now, I will use this environment variable like MySQL password. Mean admin user will create with password 1234, and root password for this MySQL database will be 1234 ABCD. Just random password I'm giving. Secret I don't want to explain you right now. The resources, this will be the resource. Restart policy on failure. Volume persistency is mandatory, for the databases, for the stateful application. So am using DataDB drivers local, and I am not going to define here any secret, any config, any network. Okay. Now why I have not defined here any deploy for the database and replicas. So by default, the replicas value is 1. Okay. And I believe there is a mistake. There should be a deploy because resources are always coming under the deploy, and replicas values is always 1 if we are not defining. Why we are using 1? We discussed this in detail in our Kubernetes session, the stateful and stateless application. Why we cannot use the same volume for stateful application um, with multiple running containers, or so that will be a conflict. So right now we are using the same volume, so I cannot set the replicas to 2 because both container will be using the same, or it can cause also the data isolation. So I just created this, and now I will do docker stack command, docker stack deploy -c the file that contains the whole manifest, whole detail of the Docker Compose stuff, all the services information. And for example, I can say app2. So uh, yes, okay, I will use app2. So now this created three things. One, first of all, it created a network. and both the services defined in this stack are connected with this network. If I run docker stack ls, you can see there are two services running under this stack. Docker service ls, you can see the three services, two are from app2 stack. This is independently ran. Let me just do a docker scale down this service, docker service scale app1 to 1. I don't want to have workload on these servers. So whatever we define in the stack file, we set up very easily. We can define number of services in a stack file, and all the services will be running very easily. So now I want to check docker service ps database is running on node 2 and web on for three replicas on node 1, 2, and 3. Now it is scheduled on node 2. So node 2 will have docker volume ls. If I do volume ls, so because this is scheduled on node 2, so here this volume is created what I defined in the stack file, and all the data docker volume inspect this volume, and under this path you could see all the data related to database is mounted at this location. So if we scale down this service, the database service, to 0 and again set to 1 just for doing some restart, and if it is scheduled on node 1 or node 3, it will not get its relevant volume because its volume is available on node 2 and all the data is saved on node 2. So this is a scenario where we have to take care. So now if I look here docker ps, we can see this container is running MariaDB, and the username password we set for the database. Let me show you quickly. Docker execute it. If I jump into this container, so here MariaDB -u root password we know 1 2 3 4 abcd we set, and we are connected with the database to databases, and MyDB is created. Okay, so it's mean the environment variable works fine. We defined in the manifest of the Docker Compose, and it's working fine. Now, this problem statement I showed you that this database can lose its data if it is not scheduled on node 2. For example, you did docker service scale app2 underscore db to 0. Okay, so it's mean it will power down its container docker service ps. You see, no, there is no workload. That container is not running here. Okay, MariaDB is stopped. Now, if we scale it up back to 1, sorry, service scale This time it is running on node 1. Docker p, as you can see, it's running here, and here Docker, a new volume is created. New volume is Docker volume ls. A new volume is created and all the data now is going under this one. So it's mean we lost everything that was already saved in the database. So this is a problem statement. So now we want to make our container persistent on specific node. How we can do this? So for this reason, we can use Docker stack to set up container on all node. I will explain you. This is a different thing. Label a node and schedule container based on label. Either I can use this command, Docker node update, Docker node update, and I will set hyphen hyphen label add, and label I can say app is equal to db, any meaningful label I can define. So I think I did mistake. Node name I have not defined. So I can say the node 2 is used for database related container. So now if I do docker inspect node 2, I believe I have to, yes. So here we can see the label section that is showing us the label is set to db. I already set this label too, but I just set this label, another label on this one. By default, there is no label. So now by taking the leverage of this label, I can use the placement constraint and the label to force the scheduler to schedule this node based on this label. So VIM app2 we have, and here under the deploy, we have to do the placement and constraint where node.label is equal to, my label is app is equal to db. Okay, sorry, I am doing this on Nginx. It should be for database 3GT, and it should be here. So now Docker service, I need to deploy this again. Docker stack deploy uh, hyphen c app2, and we have app2 stack. So it will update the service. Let's see, Docker service ps app2 underscore db. So now it's running on node 2. Now it is rescheduled to node 2 from node 1 to node 2 because we update the service. Again, we did the deployment by using the stack. It will read the new values from this file and hit apply. So now we have this container. It is using the same volume, and we can see the data that was previously saved for the database. So then this was related to the label. We can use this label, and there is one more way. We can place container on manager and worker nodes. You can do this yourself. We can set the placement constraints and node dot role is equal to manager. Okay. Similarly, we can schedule based on, I mean, manager node or worker node, anything we could define. But the question is, how does this syntax came? So its answer is, if we do docker inspect node I believe Docker node inspect, uh, node inspect, node 1. So here you can see these are all the constraints related to this node. For example, you can say uh, node.specs.labels. Right now there is no label. So I use node.specs.labels. If I show you again here, based on the label, yes, node, uh, node labels.role. So here, so similarly, we can use node hostname dot node one. We can schedule based on the host name. We can use node dot platform dot architecture. Those worker nodes or those nodes that are on X 86 64 bit, like node dot platform dot os is equal to Linux. Okay, so and similarly, you can see node.resources.nano CPUs. So different nodes can have different CPUs, and you can decide based on the number of CPU and memory. So these are all the constraints you can use to schedule your node. So we use a constraint based on label. We can use the host name. I gave the examples here, like we can use the node.role.manager. So where is this? If we see here, role.manager, if there is a worker node, it will be worker. Okay. Availability activities by default selected by the schedule only on the active nodes. So a node manager we did. Similarly, host name we can use. And there is one more thing we can use. Mode is equal mode global. So let me just quickly set up this deployment. This another application. For example, VIM app3.yml. And here what I did, there is a service. The service name is global service. Global service can be a service that you want to run on all the nodes. So that service can be a monitoring service or garbage collection service or any service that you want to run, or health check service you want to run on all the nodes. So it will automatically be spanned on one for each node. Just like I am using here the Nginx image, you can use any image. Deployment mode is global. Ensure one instance per node. Resources you can define, restart policy, port. I don't need to expose the port for this one. So if I deploy this global service, Docker stack deploy -c app3, and I can say app3 stack name. Stack name can be different than the file name, but I am using the same. So, oh sorry, -c. So it is creating its own network and connecting this service with its network to Docker stack ps, sorry, ls. And there are two stack. App3 has one service, and Docker service ls. This app3 global service is created 3 out of 3. I have not defined any replicas. So in the global mode, we don't need to define this replicas. It will automatically be used according to the number of active nodes. So Docker service, yes, name of the service. So you can see node 1, 2, 3 each contain one container. So this was related to global. So you can use the host name too. Just like I will give you an example here, like manager, you can use worker. You can try this. If you are getting any issue, you can contact me. And node global, and similarly, let me show you from here the when we did the inspect, so we can see its role and node name, the the host name. The host name we can set, and we can use, for example, app2. For example, I want to use here node dot host name. H is small, and host name I can define node2. So now it will be scheduled based on the host name. So these all methods we can use. Now you understand the concept of the stack. We can expand our stack with the volume we created. We can create a specific network too. Like we can add this network section. By default, when we deploy the stack, Docker network ls, you can see its own network is automatically created. You don't need to take care. But if you have multiple services in a stack and different services want to use different networks, then you can create multiple networks and you can attach them to isolate those services. But the good practice is always use a different stack file for all the services that have to communicate with each other. App2 YML, what I will do here, just add this section network, and here networks and the name of the network, my network, or you can say this is my app2 network. There is a hyphen before this. So I connected both the services with the same network. Similarly, we can define here multiple networks. So let me save this. Docker stack deploy -c app2 uh, app2 Docker network ls. This new network is created with the name app2 network because it is using the file name and the service name, combination of the file name and service name, and the service name, sorry, the service name and the name we defined uh, in the file. So it should be like app2, not its service name should be is automatically self-explanatory. So I can say only network, and docker stack ls, docker stack rm. We can remove the stack. It will delete all the services deployed along with the networks, everything. And docker stack deploy -c app2 and app2. So yeah, again the name is created like this. It is creating two network, undefined network. Yes, we must have to use the same method. We cannot use like this. I think the service name I have not upper service network I have not changed. That's why it create the problem. Let me again remove the app2 and stack deploy. Yes, now it's good. So you can see Docker network ls. This network is created and Docker service ls app2 and app2 web, and it's trying to create now. So I think it is still in the process of creation, and I believe I made any change, that's why it's taking some time. So this was the concept of the network, and so now we understand how we can schedule based on our own requirement. Now the last thing we have to understand is about the secrets and config management. If I show you this file that we created, app2, here you see the password is in the plain text format, and this is not a good practice. If you want to set the password for, if you are using some sensitive information about any application, you should not directly write in your manifest, because your manifest, you can commit this on the git, or but it is not safe. So it's mandatory to use the secrets as an input for the variables to provide their values. So how can we do this? Let us first create some secret and then we will modify this uh, stack file. Okay, so I will create here a secret using Docker secret create, and name of the secret I can say the root MariaDB user, any meaningful name, and then the file name or path we can define here that contains the password. The we can also use this secret to totally encrypt our whole config file. So that's why it can take an input as a file. That file can simply create a single liner password, or it can be a complete config file. It depends. Maybe your whole config file is critical. You don't want to save it as it is in an unencrypted format. So you can use a secret. So you can also use a echo, for example, 1 2 3 4 ABCD. I want to set the password and pipe sign, and this hyphen will take an input of this echo. So Docker secret ls, this secret is created. Okay. So now this secret, how we can attach with our stack file. So we have to use this format in the app2 file. I will add here secrets, and this secret I will set the secret name, this one. Okay, and external true mean it's already created. We can directly create here, but that's not a good practice. We define external true mean this secret is already defined. Also, we have to add here secret. Let me just confirm secrets and the name of the secret. This name of the secret. So now this secret will be exposed inside this container. So let me show you. Right now I am not using this secret value directly into this variable. First I will show you how this secret will be exposed inside the container. So docker stack deploy -c app2 YML and app2 stack name. Docker service ps app2 dp. So it's running on node 2. Let me go to node 2 docker ps. This MariaDB is running 12 seconds ago. Docker execute it and into this container under the run secrets. The secret is exposed as it is in the file with the name we created as secret, and that secret does contain the password we created or whatever the, if this is a config file, it can contain the whole stuff. So now we have to use this path as an input for the variable that we define in our stack file. So app3, sorry, app2 YML, and here I will define this path as well as the file that will be created under this container and the variable that I will use as file. So this is a variable defined in the MariaDB that will read the password from this location, from this file, and will store in this MySQL root password. And when the database will start very first time, because right now the password is already saved in the database, but if this is the first time, it will use the password from this file. Same method you can use for this one. Okay, you can use MySQL password underscore file and then the path of the secret that will be exposed. And here you can define the multiple secrets, and here you can define the another secret like this. For example, let me show you. Like your another second secret is admin pass. So same like this, and here you can add one more line. Admin pass. But right now I'm not using, you can practice this. So with this way we can use this variable. So let me now just docker service ps app2 dp. So it's running docker service scale to 0. It will shut down the container. You see, it was running. Now I automatically exited from this container and there is no container running. Now docker volume ls, docker volume rm. I want to delete this volume because I don't want to volume is in use. Response from daemon is in use. I think docker ps minus a. Yes, this is still using. I need to docker rm minus f this container forcefully and docker volume remove. because I scale it down to 0. Now when I will scale it up to 1, I believe it will create a problem. Let's see. It will automatically create the volume or not. It's created and Docker volume ls. The volume is created, okay. And uh, now if I go to this Docker execute it this container and MariaDB hyphen u root hyphen p. Yes, I use the same password what I defined in the secret. So this it works. So this was the explanation about the secrets. Now the last thing we have to understand is about the configs, config management. So what is this config management? For example, you have an application that is built by the developer, but that application you have to define deploy in different environments, just like dev, test, QA, prod, and each environment need a specific configuration file for that application. For this reason only, you cannot rebuild your image every time to just update your image with the new config file. So we can define our own config file in the database of this Docker Swarm, and we can map that config just like a volume with our container, and it will be reflected there. So I will show you how we can do this. So I will create a config here. So you can think like the config is just like a file that is saved in the database of Docker Swarm cluster. Docker config create, and then the name of the config I can say just like dev. Any name you can give, any meaningful name, just like dev config. Okay, and then the name of the file. So file I have not created so far. So let me just create a dev dot conf, and I can put in any syntax that is given by your developer. You can put here in this file that will be used by the application. So I'm just creating a random file just to show you how it will be mapped inside the container. And this is config file for dev used by created by Docker Swarm. So what I have to create dev config with the path of the file we have. So file is at the same location, or the relative path you can give, or absolute path you can give. So Docker config ls. So this config is created. Now we have to use this config with our stack file. So I will use the same stack file app2, and here we can define config. The config will be something like, and the name of the config we created is dev config. So dev config I added here. Now in the service is section, we have to define the config portion. So this is dev config as a source and where we want to map it as a file. I just created this random location, whatever location needed by your application you can define here. So I just set like dev app conf. Now I will do docker stack deploy -c app2. So now docker service ls docker service ps. This web service I want to see on node 213. Everywhere it's running, on node 1 is running. So docker ps, just I believe it is not reading the new value because it's running 45 minutes ago. Let me just quickly jump into this container. Docker execute it etc nginx, nothing like this. So it's mean we must have to docker service. We have to remove this service app2 web service. We will remove and again we will reply the stack. Now docker service ps on node 1 it's running, and docker ps it's running nginx 46 minutes ago. Why? Sorry, it's app3, but okay, so now this container comes up. Actually, this container was for different app3, but now global service we created, but just 49 seconds ago this container created. Now I will jump into this container, any container that is related to this service, and inside the etc nginx you can see this file is created, and this file contains the same stuff we defined in the config. So with this way we can define multiple configs. This is very useful to dynamically update the data of your application without doing the main modification inside your container. So if I just go to any other node, docker ps, let me show you the about a minute ago this container app2 I've created. Docker execute it this container, and under the etc nginx the file is this. This file does contain exist, just cat same file. So same config is attached with all the containers. So this was about the config. So here we completed our whole cluster setup, everything we discuss in detail. So in another series, we are going to discuss in detail the monitoring of Docker Swarm by using Prometheus and Grafana and alert management. But these two sessions were only to understand the concept of Docker Swarm. If you have any question, you can write me.